Okay, morning grade 10. So we're going to look at solutions today. So you need to know two definitions for the section. Firstly, the definition of the word solution is when you have a mixture obtained when a solute is added to a solvent, usually dissolved but not always dissolved. Your solute can also be a liquid or a gas. Okay, so it's just a mixture obtained when a solute is added to a solvent. And then there's also the term standard solution. That is when you have a solution where the concentration is known. Okay, so it's the same as a solution, except it's a solution where we know the exact concentration of the solution. Okay, now before we actually start looking at calculations, I just want to get some terminology out of the way. I'm realizing the solute and solvent, you might be a little bit confused. It doesn't help that all the words start with an S. Okay, but just so you can have a look what happens when we form a solution. Let's look at that. Forming a solution. Okay, so we will start with a beaker of something. Usually we do aqueous solution. So remember, an aqueous solution is a solution where your solvent is water. Okay, so usually we deal with aqueous solutions, but it doesn't have to be aqueous. But whatever you start with, your liquid, usually water, we refer to that as the solvent. Okay, so the liquid that you start with is your solvent. Then into that solvent, we will add solute. Okay, solute is usually solid, but it can be gas and it can also be liquid, whereas your solvent is always going to be liquid. Okay, and we will pour our solute into our solvent, and that will form what we call our solution. Okay, so we'll be left with our solution. Okay, now our formula that we're going to use here, there are two. Okay, we can either use the fact that the concentration, now on our diagram I'm going to label what I'm talking about. So the concentration of our final solution, I'm going to use green for this. So the concentration of our final solution is equal to the number of moles of solute added. So our number of moles is the thing that we added, divided by the volume of our solvent. Okay? Or our second equation is that the concentration, if we don't know moles but we know mass instead, we can use the little revised equation, which is the mass of our solute. So moles or mass, depending on what you have, is equal to, the concentration is equal to the mass of your solute divided by the molar mass of your solute times the volume of your solvent. Okay, so I will write down what all of these are quick. So C is the concentration of solution, and our units are in moles per dm cubed. N is number of moles of specifically our solute, the thing you add to the solvent, and that's obviously measured in moles. Our V, and it's a lowercase v, is volume of solvent, and that's measured in decimeters cubed, same as the V in the equation we did yesterday with gases. Okay, so same units of measurement. And then moving on to this formula, we've got M there. This is going to be the mass of your solute in grams. And what else do we have? Molar mass. M is the molar mass of, again, your solute. And this is always measured in grams per mole. Okay, I can't close the bracket there. And a reminder, this you get off of your periodic table. Okay, so that is the basics of this section. It's more calculations than anything else, and we're going to add dilution to it, but we'll do that one tomorrow. Okay, so I'm going to quickly pause you, erase this, write down an example that we can do together where we actually apply this maths. Okay guys, so there's our first example. We need to determine the volume of water required to form a 5 mole per dm cubed aqueous solution from 10 grams of sulfuric acid. Okay, so let's unpack the question firstly. We have a solution, okay? As soon as you know we've got a solution where we've got a liquid and we're adding something to that liquid. We've got water and sulfuric acid. Okay, so we are forming a solution. So we know we're dealing with a solution. Now in order to unpack the questions, so what I like to do is first identify what my solvent is, what my solute is, and what I know about each of them. So my solvent in this case is water. We're forming an aqueous solution. So my solvent is water. And the solvent, the only thing we need to know about it is the volume. And that's what they're actually asking us. Okay, now let's look at our solute. Our solute is sulfuric acid. We need to write it in its chemical formula way. Okay, you'll need its chemical formula just in case we need to work out the molar mass. Write it as a chemical formula. Our solute is H2SO4, and we know that the mass of that is 10 grams. And what else do we know? We've been told this 5 moles per dm cubed. They don't tell us what it is, they just say we want to form a 5 mole per dm cubed aqueous solution. So you actually have to identify what this is based on the units. Those units are for concentration, which means that is the concentration of our solution. Okay, now let's first quickly check, is everything in the correct units? Yep, that must be in grams and that must be in moles per dm cubed. So we can jump straight into trying to figuring out how we're going to solve this problem. So we've got mass, we've got concentration, we want volume of solvent, and we have a formula we can use there. We can use C is equal to M over MV. Okay? We know the concentration of the solution, we know the mass of the solute, we want the volume of solvent, and we can quite easily determine the molar mass of our solute. Okay, so we write down the formula because it's worth a mark, and then we start substituting. So concentration is 5, mass is 10, molar mass of H2SO4 is going to be 2 times the molar mass of hydrogen plus 1 times the molar mass of sulfur plus 4 times the molar mass of oxygen, and then multiplied by our unknown volume V. Okay, now I'm actually going to show you this one step by step how we're going to solve it, because I know this is something we tend to struggle with. So every single time I see a question where I've got a fraction and just one thing on the other side, I turn this into a fraction and I just cross multiply. Okay, so I'm going 1 times 10 and then 5 times all of this nonsense. So 1 times 10, we've got 10, and 5 times all of this nonsense is 5. 2 times 1 plus 32 plus 4 times 16 V. Okay, now we can simplify all of this. Okay, so it's 2 plus 32 is 34 plus 4 times 16 is, okay, let's go for it. 2 plus 32 plus 4 times 16. Oh, no, man. Sorry, my calculator's in scientific mode. Okay. 2 plus 32 plus 4 times 16 times 5 is 490. So we've got 10 equals 490 V, and now I think you can code from here. We're going to divide both sides by 490. And we get that the volume of water required is 0.02 decimeters cubed. Okay, not too bad. Okay, I'm going to pause you and we're going to write down a second example, and then I'm leaving you guys to do your worksheets. Okay guys, so here's our second question. We've got 7 moles of HCl being added to 15 grams of water with a volume of 15 moles, and we have to determine the concentration of the solution. So, first off, we're dealing with a solution. It says it in the question. So we know that we're either going to be using C equals N over V or C equals M over MV. Okay, definitely not N equals V over Vm. This is not a gas, we are not at STP. Okay, so even though we're talking about volume in here, this is not correct for the scenario because this is not a gas at STP. So you do not use that formula, please. Okay, so let's first identify what we have. So remember, that's what I like to do. I like to go, I've got a solution, I've got a solute, I've got a solvent. I like to identify which is which and write down what information I know about each. So my solution, the only thing about the solution that we might know is the concentration, and we don't know the concentration. They're actually asking us to find that. So for the solution, we're looking for the concentration. Okay, the solute, that is what you add to your liquid. So our solute is HCl, okay, hydrochloric acid. And they say we've got 7 moles of HCl. So they've given us that N is equal to 7 moles. And then our solvent is water. And they've given us the mass of water. Anywhere in this formula is there a space for the mass of the solvent? No. This M is the mass of the solute. So this 15 grams of water is completely irrelevant. We do not use it. There's no space for mass of solvent in our formula. So we've got 15 grams of water. Cool, don't care. With a volume of 15 moles, this is what I care about. Okay, so I know the volume of my water, the volume of my solvent is 15 milliliters. Okay, now let's go ahead and check if everything is in the correct units. It's not. That's moles, that's fine, but milliliters is not what we work with. So quick reminder, we did look at this when we looked at gases at STP, but we use decimeters cubed for volume. A decimeter cubed is the same thing as a liter. To get from milliliters to liters, we need to divide by 1,000. Okay, so volume is in milliliters. Don't want that. That's going to be 0.015 liters. Don't want liters, that's 0.015 decimeters cubed. Okay, now we're done with our unit conversion. Okay, so we want concentration, we know moles, we know volume. Nice easier one here, we're going to use that formula, hey? So we write down our formula because it's worth a mark. So we've got concentration is moles over volume. And we substitute. So moles is 7, volume is 0.015. And when you say 7 divided by 0.015, you get a big number, 466,67, and its concentration, so our units are moles per dm cubed. Okay, and that's all there really is to it. I do want to draw your attention, just sort of off topic, but of all the formulae we've seen so far, so we've seen N equals M over M, we've seen N equals V over Vm. Remember, this is for gases at STP. We've seen C equals N over V, and we've seen C equals M over mv, and these two are for solutions. Okay, so for all of these, I want you to have a little think to yourself, what is the relationship? Okay, what is the relationship between moles and mass, and between moles and molar mass? So I'll get you started with the first one. A reminder, if you've got your subject and something that's at the top of a fraction on the other side, those are directly proportional. And if you've got your subject and something that is at the bottom of the fraction on the other side, we call that inversely proportional. So this is direct proportion, and this one is inverse proportion. Okay, so I want you to just actually have a look at these three as well in terms of that. So see, how does moles relate to volume? How does concentration relate to moles, and how does it relate to volume? Or mass and volume, that sort of thing. Okay, because can and will be asked in a graphical way in any time you have an equation. It can and will be asked graphically. So you saw that already in your last test with Mr. Solomon's nasty graph with FNet and MA and that sort of thing. Okay, so anything can be asked graphically. Make sure that you know what the relationship ought to be. Okay guys, so you've got a worksheet to do on solutions. Let me know if you get stuck. I will also send it through to you on WhatsApp.